Hello, Dr. Ammar. It's a pleasure to have you.
Hello, the pleasure is mine. You think we can start now?
Yeah, of course.
Okay. So, hi everyone. First, it's a pleasure to be here, and I'm extremely delighted that you guys chose to attend this session. Just to start with, this session isn't going to be long. We're gonna need like 30 to 40 minutes max, but it's gonna be intensive on thoughts. So bear with me on thoughts here. What I'm going to be talking about is graphs, and I'm not going to be talking about graphs in the sense of we need graphs, for example, to do to do some representation of data, like to do some crossing BFS or something that. No, we are interested in how to build graphs from other modalities of data. So the title of our discussion is From Rows to Relationships: Why Graph-Shaped Data Supercharges AI. So let me first share my screen so we can also see this presentation. So I can confirm that you can see it.
Yes.
Cool. So to start with, um, today we're going to have a beginner's journey into the world of graph-based thinking and how it transforms AI capabilities. What we want to talk about is not anything related to graphs other than our intuition behind AI and our conclusion that we eventually need to have graphs, because graphs have the whole answer there. There are many things that AI is currently suffering from, and we believe that graphs might be the answer to many of these questions. So this is our starting point, and this is where we want to start our discussion today. So we need to talk about the problem with rows. What's wrong with having tabular data or having image data or having audio data or any other modality of data? We're going to talk a bit about the graph fundamentals, about the real world applications of graph, and how to get started with this kind of science. And again, if you look at this journey here, we're gonna be discussing the problem, like why are we even talking about this topic? We're gonna discuss the tool, how to apply graphs, and eventually real world applications, which is related to what applications out there already uses graphs, and eventually getting started, like starting to do things yourself. Is everything going well online? Do you have any problems? Cool.
Yes, all is good.
Okay. I'm not talking about data visualization. I'm not talking about I'm not talking about dashboards. I'm not talking here about like knowledge graphs. We're gonna touch on that, but this is not our topic. It's gonna be clearer, hopefully, with the following slides. So I want to start with a story today. Imagine that you purchase a certain headphone online, and then 2 days later, your friend buys the exact same pair. The causality of how this happened isn't a coincidence. Basically, you recommended the headphone for your friend. So, in traditional row based data, um, these appear to be two separate instances. So, if you think of it again, if you go to Google today and you download a data of some purchases happening on a store, these two facts are basically separate. There's no connection between you buying the headphone and your friend buying the headphone. This is basically something of an information that we have lost. And it is an important information because if I want to make a recommendation system, I'm going to be relying on these, like this word of mouth that is going around, right? But if I choose to save my data in a tabular format, I'm gonna have to lose this. This is gonna be lost. This is an information that I'm gonna certainly lose by my design and not for any other reason. So that is saying that there is a problem with tabular representation. There is an information that we are losing. So the causality, meaning that your purchase like influenced your friend's decision, is completely lost. And therefore, I'm gonna be relying on pure statistics to understand that your that this like relationship between you and your friend, you are both Gen Z interested in this headset, like this relationship is gonna rely on pure statistics. If statistics and probabilities played in our favor, we will be able to detect and understand that both of you guys are interested in this because there's a word of mouth that happened. If statistics played in our favor, if it didn't, then we're gonna lose the information. There's no information there anymore. So this is a story, a simple one, that gets you to the understanding that yeah, there's a problem. There's a real problem with like tabular data and how we save data, and there's a real problem that we're losing data. We're losing information, and this information is what AI needs to thrive. So if you throw the library, like for example, this is an example that is similar to what we're thinking of. If you throw dictionaries to an LLM to train it, it will not be able to talk, right? It will not be able to reason normally. It will just be able to tell you like the definition of like some things. So for the past couple of years, everyone have noticed that um, we need multi-modalities. So now, in order for you to understand what I'm talking about, you would need the following. You would need your ears to hear me, you would need your eye to read the slide, and you would need your eyes to look at me so you can get the interaction and what I'm trying to say. So this have been the case for some time now. And if this is the situation, then it is a fact that for the previous years, we've tried to force every data type into text so language models could understand it. So we tried to change tabular data or JSON data into structured data into paragraphs. We tried doing some transcription for audios. We tried captioning images like a blue car in a video or something. But what's common about these like different like use cases? Those are trials to convert data modality from one modality, could be audio, video, image, anything, into text modality. Because LLMs appear to be working well with text. But that's very problematic because the moment we convert an audio like a song to a transcription, is gonna be like normal words that are like floating around that are like really weird to think of. So the moment we convert to text, any other modality, we amputate structure. Language is linear; it cannot maintain pointers, order, or any other multiplicity or so on. So when you transcribe an audio, you're gonna lose the tone, the speaker relationships if you have multiple speakers in one audio file, the emphasis. So it differs, like if I'm talking about a certain topic and I was like, and this is the important thing, like this tone is what tells you this is coming to be an important thing. So you lose all of this if you're just like using the linear method of like text, like audio to text to LLM. Again, I'm saying this because there are many podcasts that are used as like data to feed the training of the LLMs. And what I'm advocating here is that like transcribing the podcast isn't enough. It doesn't give you the full information. There is still some like some knowledge that we are losing, and this is all a knowledge discussion here. So we want to move from blindness to relationship sight. This is what I call moving like from blindness to sight. It's all about like looking at the problems that are within traditional like table or data that is like widely out there or any other data modality. So what's the connection between two frames of a video? It's like this frame comes before the frame after, right? So this connection isn't complete, right? Because if you think of it, there's another dimension. There's a car moving, so it needs to be like if it's coming in our way, it needs to start small and then get larger. Because if it does the opposite, it doesn't make sense in physics. So that's a rule. Another rule is that if like the car is far and it has a loud sound or something, coming towards our way is gonna make the sound higher, and many, many other connections. All of those are lost as soon as you convert your image data, your video data into captions of frames. So traditional data treats each row or each data sample as independent and identically distributed, so IID data. So there is no inherent connections between data points. There is no, like the context must be manually engineered as features. Temporal and causal relationships are lost. And this is one of the problems that we noticed in like the era of deep learning when like we had a video of a cat and we want to try and train a cat versus dog classifier. And what we did is that like we decided that like a wise thing is to go and extract 100 frames from 100 frames video, and each frame is now a different image of a cat. And we treated this as like IID data, while it actually isn't IID data. The previous cut is the same one as this cut, yet it moved like for like 1 millimeter or something. So this is row blindness, but it doesn't have to be a row. It could be any data sample, any data modality. We're advocating for relationship site. Data needs to be connected. Graph-based data preserves connections. And now we're going to define what graph is, but like, let's not do that now. Explicit relationship between entities. So I have a car that is on the road that is going towards something or away from something. I have someone in the car, like all of these connections, right? It cannot, like the nodes of what is happening and like when to do what and so on. So imagine you have someone in the car in frame 10, and this person leaves the car at frame 15, right? So what happened here? I'm gonna, like, if I use the traditional method of row blindness, I'm gonna have a caption of like on frame 10, someone is in the car, and then on frame 15, someone left the car. So there's no connection between them. This is someone and this is some other one. While in graphs, I can make the case that someone is gonna, like, I have one car and someone entered that car and someone left that car. So I can make the connection that this person is the same probably as that person or something like that. So again, to some theory here, like very basic things. What are graphs? What's graph theory? I'm not gonna go into any detail here. Graphs are made of nodes. Those are the entities, the objects, like a car, like a person, like a product, like a location, something like that. We have edges, which is the connection between these nodes. So I have a car and a person, and this person is driving this car. So the connection, the edge is the connection, is basically driving or like visiting this house or like doing some action. And we have paths, which is sequences of nodes connected by the edges, right? So I can go from here to here to here to understand a certain information. And at the end of the day, we have degrees, is like how, like what's the depth of path that I need to traverse. And just think of a metro map or a social network. These two are great examples of data that is born to be graphs. This is data that is natively of type graph. And before going here, let's just like go back and think of why is this data modality not out there? Like what's the problem with that modality? Uh, why do you hear about images, audio files, like text, like time series, table, or like anything, but you don't really hear about graph data? I need you to comment, to think of this while I present the next few slides and we can go back to it. Like, why do you think that this modality is not out there? Like, rarely you see someone talking about like graph type of data, right? So why is this the case? That's like extremely weird, I think. So we have a metro map, for example, and in this metro map, you have stations that are nodes. Those are connected by lines, which are paths, and we also have like these paths are the same as edges, and the map structures reveals the transfer points, the high degree of nodes. Like if you want to move from many to many, you need so much time, and it's very low. The audio is very low. Um, Let me try out something. My audio just got lower. Give me a moment. Uh, these are the AirPods. Sarah, can you confirm if it's actually low?
From my side, the audio is good.
Is it possible that like the streaming thing is causing problems?
Uh, let's try now.
Okay, chat, is it going well now?
Yes, it got better.
Okay, cool. Sorry about that. Let me share my screen again. It's shared. Cool. Okay, so again, the metro map and social network example. We have the metro map, which is made of stations that are points connected by train lines, which are the edges. And the map structure will tell us exactly like how to move from one edge to the other, the optimal routes, the network resilience, how many like single points of failure do I have, and so on. This kind of data is of type graph to start with. So it's not of a certain type and then it moves to be of type graph. It is there's no effort in making this graph, this data as graph because it is made to be a graph. Again, another example is social networks. You're a friend of someone, someone is friend of someone else, you belong to a group and you follow a page. This is graph. This is graph to begin with. But again, going back to our question, why do we hear of all modalities, but like we don't hear about graph modality? You don't find many, there are, but you don't find many Kaggle data sets that are graph. Although they make total sense. Imagine like you have a connection with this person and this person has a connection with that person. So making this graph is going to tell you how to connect with that person if you need it for a business case or something. Not sure, anything. So the reason is like there are many reasons actually. Yeah. So the reason like one of the reasons is um it's actually the main one, I think. It's because graph modality, like whoever has the data that is of type graph is extremely ownership. So they own it. So Netflix owns their data and Meta owns their data. Instagram owns their data. So you're not gonna find data out there that is built to be of type graph because the amount of information that is within that data, specifically if it's social media or something like that, is humongous. And if it's that much information, it's not easy to share it or just to publish it online. So, for example, if you go on X and you look at like 20 accounts or 50 accounts, at a certain moment in time, you will get blocked. You'll get blocked to access any accounts today because someone would suspect that you are scraping. So this is a proprietary information that you cannot actually share or scrape. So this is one of the reasons. And this is also one of the reasons why we are not exposed to these recommendation engine algorithms that are based on this like graph data. The recommendation engine is like it eats graph data. And if this is the case, we must be aware that this is the reason. And if this is the reason, this does not mean that we just surrender and we don't tackle this kind of modality. So that's basically what I'm trying to say here. Knowledge graphs is adding a bit of meaning to this graph modality. So it's a semantic layer, like so the knowledge graph layer semantics on top of the graph structure. So first you have the graph, which is like graph theory. And then you have labeled edges that we already established. Then you have the ontology. And ontology is basically is like formal definition of entity types and relationship rules. I'm not gonna dive deep into those, but you should have heard of knowledge graphs. And knowledge graphs is one of the manifestations of what we're trying to say. Our goal is not to get there. We don't really care about knowledge graphs, but like the manifestation of knowledge graphs, the manifestation of the importance of graphs is within knowledge graphs. And it is like an easy way to start understanding and working with graphs. So let's have this example. In this like healthcare knowledge graph, we have a drug that's a node connects to a disease, which is also a node. This drug treats this disease. So the relationship between the drug and the disease is treats. And then the relationships, as you can see, are labeled, okay, like forget the AI generated images. The relationships are labeled treat or like is like cannot go with or something. The graph basically enables complex queries like what drug treats X, but are not contradicted for a patient who has the condition Y. So someone has diabetes, needs a certain drug. So there are like all of kinds of connections between drugs, like different drugs that cures a certain disease, but these drugs can contradict with other drugs that the patient is taking. This is a use case for knowledge graphs. So if you're in the domain of pharmacy, or you know someone who's in the pharmaceutical domain, maybe you can build something like that. It seems interesting. So now, what am I trying to say here? Like, why are we even talking about this? Like, why did we make the case that graphs are pretty nice and like they make sense and so on? The key innovation uh, is about treating any signal as a living network where relationships become first class data or first class citizens. And what I'm trying to say here is that instead of grounding our data towards text, I'm a proponent of grounding our data towards graphs. And when we say grounding our data, مثل ما كنا we're doing previously, we had a video, we captioned the video, so it's a text. We have a JSON file, we describe it, and now it's a text. We have an audio file, we transcribe it, and now it's a text. This is exactly what I'm trying to say here. This multimodality is the case where we transform any data modality, was it a video, an audio file, something, into graphs. And this is where I think the next layer of AI knowledge site is going to be. So pixels in videos or objects in videos, this is wrong, not pixels, they become object nodes. So I have a car, I have a person, I have like a cat, something, and all of those are now objects. And they interact together because like the scene is made out of these like nodes doing something. The car is moving and the cat is jumping and whatever. So if you could represent this video as a graph of nodes and connections, then you'd be actually able to first compress the video. And second, to understand the timeline of the video. So you're gonna see the cat jumped on the car first, and then the car went on. So we have an accident of some sort, right? So this is it. Interactions become timestamp edges. So each edge, just to keep this like video timely connection, each edge is something that is timestamped. And audio features connect to semantic meanings. Sensor data links to physical events. All of these together, so instead of flattening data into text, we preserve its natural network structure, yet in a graph modality. And you might ask why we would do that. But because imagine you have a video and you have a PDF, and then you have an email stack, and then a browser history. And you want to combine all of those into a single knowledge set. At the moment, when you do RAG, for example, or CAG or something, you don't really embed the images. And if you do embed the images, those are embeddings that are coming from a different space than the embedding we embed text with. We have image embeddings there and text embeddings here. So those are apples to oranges being compared. So it doesn't really make any sense. Now, with that said, I built something I published on my LinkedIn. You can check it out. I'm on LinkedIn. So in this demo, I have video frames that are taken. So I did grounding to text, but this is not the goal. So video frames are processed to identify the objects that are in front of the camera. So what's happening, and I open up a camera just like you're looking at me at the moment. And I have an LLM locally that takes in, like a VLM actually, vision language model, that takes in this like video of me and captions it. But what happens here, yeah, thank you, Sarah, for sharing. But what happens here is that these captions, these like series of text that represents the series of frames in the video, together are making a certain graph. I wouldn't say it's the most successful graph in the world, but it's a graph at least. So we were able to move the modality of video to graph, and I think that's interesting. So video frames are processed to identify objects. Then objects become nodes in a dynamic graph. Interaction between objects become edges, and temporal information is preserved in the graph structure. So it goes from like left to right. So first the like man takes a selfie, and then man like is wearing something, and then whatever happens, right? So AI now, if you send this graph, as you can see, there's an export JSON here option. It's not very visible. You can see it on my GitHub. I'm gonna share the link for it. Yeah, so if you export this file to be a to be a JSON, you just send this JSON to an LLM, and it can really understand the video, the whole thing. So that's a compression tool in a way, right? Let me send this over. Yeah, so that's a GitHub. You can try it out. I think I made it everyone can run it. It's Dockerized and so on. Another situation where text-only grounding falls short. Imagine you have a blue car that comes in frame 12, and then in frame 47, it has a crack in it. So if we don't look at the accident itself, we will not really understand why is we won't really understand why did it crack, because we know that we only know that at frame 12 something was normal, and at frame 47 something is no longer normal. So basically this is losing information. Audio transcription again is gonna, like rich audio with multiple speakers and tones and emphasis, become flat text without like if you do transcription, so you're losing the whole information. So language is a single file line. It cannot maintain pointers, order, or multiplicity again. So what are the different benefits of graph modality? um, Graph modality preserves causality. And causality is a very, very important thing in reasoning, because if you know that your friend bought this headphone and is happy with it, then you know that you would buy it, that you would be a bit more lenient to buy it. So, and if you know that like these two are friends and they both bought this headphone, you would know that this person recommended the headphone for the other person or something like that. Propagating context is also an important thing because if we're talking about the same person and this person is out there in different modalities, let me show you something here. So you can see my screen. So I made like this simple website. You can try it out. I'm not sure if it's still working. It's probably outdated. Let's try. So let's say Lebanon. I want to know everything about Lebanon. It's gonna probably fail. I revoked the API. Oh, it's good. No, it failed. Okay, you're not lucky for the demo, but like basically what happens is gonna go scrape like all of the topics about Lebanon, and then using this scraping is gonna do multiple levels of like propagating of the context. And then whenever I ask another question about Lebanon, this context is gonna be preserved. Anyway, um, and again, you have a like Cristiano Ronaldo, you have some information about the guy, and then some new information comes in. I don't want to make another node that represents him. I already have him there. So I just inject it to the edge I already have. Again, one of the main and most important benefits of graphs is that they're explainable. They're somehow, to some extent, explainable. If you know, if you follow a certain path in a graph, you could certainly understand how this happened. It happens when you have like in social networks, when you have like the police like following the connection between people, that is like this person knows that person and this person knows that person. These two are now connected, right? This is a way to use graphs. Now, my goal here is to unify modalities. So our digital workday, like what we do on a daily basis, is everything clear? Do we have questions, thoughts, ideas, something? Complete silence. I think we lost the audience. Okay, the audience is laughing. Maybe they're understanding everything or they have no idea what's happening. Cool. Let's keep questions to the end because there are many. So our digital workday, like if you think what you do for work on a daily basis, um, if you think of what you do on a daily basis, basically what you do Slack, you do emails, you do history and browsing, you do tabular data, you do like a to-do list, like Notion, like notes on your phone, all of these data, right? And all of this data is now isolated, and this isolation makes it in a way that is totally lost. We have so much knowledge, but again, this knowledge is basically spreaded in many places. Imagine just the connection between your browser history and your email. So when your boss sends you an email to do something, you're gonna go do it on your browser or on your code or something, right? So that's basically what's happening. So we start with information silos, and then we need to think of ways on how this would be integrated in graphs. Um, so all digital artifacts become nodes in a connected knowledge graph, preserving relationships between ideas, conversations, and tasks. And this is extremely important to then having a graph that represents these different modalities. I have a video about tennis and then like the news of tennis and like some like newspaper and some discussion on Reddit. You need to normalize all of those in a single graph so it would be compact and AI could benefit from the relationship. something funny happened in the parliament in Lebanon today, and then you have some analysis and some commentaries and so on. In order to understand the context of what's happening, having the data as a graph and as a single modality, which is now graph, is extremely important, in my opinion, at least. What's up with that? Okay. So we are not the first ones who are talking about graphs. Most of the major companies already have major departments that handle graph data, basically for recommendation systems, for recommendation engines, and so on. We have SAP, who has like their knowledge graph, enterprise data connected across silos. So they work on unifying this data into a single knowledge graph. Netflix has the model once called it's called a model once. It's a content graph connecting shows, actor themes, and viewing patterns for better recommendations. Samsung on-device graph, it uses interactions modeled as a graph for privacy-preserving personalization. So you have personalization in a single in a certain like privacy-preserving situation. Industry leaders are already shifting towards the graph-based data representation. So this is something that is coming. This is something that is already in major companies, yet uh, yet it's not industrialized well yet. So if you're gonna go look for a job in like graphs, it's gonna be kind of hard. So how to start? Um, Again, just to clarify, my goal and my call here is to um, try to make demos and methods to change some data modalities into graphs. Imagine you have Slack. And Slack, you have a discussion between many people, and then you have some common channels, some private panels, and so on. Imagine you were able to export this whole conversation and you want to like you want just to visualize it as a graph, like the whole Slack scene. How would you do that? How would this process look like? We have no method to do this because every modality, no, this isn't data visualization, I said. I'm talking about changing the modality. So the data that used to be Slack on Slack as like conversations and channels and so on is now a single graph. This is what I'm talking about, like moving from one modality to the other. So it's basically changing the dimension of the data. And basically, once you have like this idea in mind, you need to think logically of it and try to do it because this isn't a solved problem. This is something that is still heavily under research, and there are not many people interested in this domain, although it makes absolute total sense. This is like, who can deny these facts? Who can deny that having graph-based data is better? Who can deny that? Like, okay, so I'm talking like someone would come out with the argument saying, yeah, but like who can also deny that having flying cars is nice, but like we don't have the tech for it? I agree. Like if we have it, if we have the tech, that would be amazing. But like whoever asks for flying cars is do not live in our same dimension. But like eventually, in the world of AI is making wonders really fast. So why don't we steer this way? Why don't we go and try to mix modalities? And you can use like open source tools like Neo4j for knowledge graphs and not Network X on Python to just like make a prototype and so on. And that's basically it. This is the like how to start in this domain. Again, this is a bit more tools on graph experimentation. You have graph databases like Neo4j, Neptune, and Tiger Graph. Programming libraries in Python, Network X, and PyJ in Python Geometric, and Deep Graph Library. Those are all available. Um, there are many pitfalls, and we should not think that we are the first ones who started doing graphs and who got this idea. Many others tried to do it and they failed. So we just need to be aware of that. Um, Schema sprawl is basically starts like it's usually important to start small and then scale with time once you achieve a milestone. So you could consider that like the first milestone of Slack is I want to represent the team, and then I want to represent the team dynamics, and then I want to understand the I want to represent the team roles or something as well. Over engineering is basically creating very, very complex graphs that are exactly Mars daily. So over engineering is basically creating complex graphs that are like over engineered in the sense of they are very particular to a certain situation or a certain scenario. And then ignoring time and the lack of governance are two other pitfalls in the field of graphs that starts yet they don't end much. I added like a simple example here. It's a simple query to find friends of friends who bought headphones. Once you have the data as of like modality graph, this traversal follows relationships to discover insights that would be nearly impossible to do in row-based queries, right? So uh, this person needs to be friends of myself or friends of my friends, and he purchased headphones that I bought. So return the name and the brand maybe of the headphone he purchased. So this is something that is like really interesting to look at if we were ever able to do that, to represent like all modalities in graph. Once you do this and like you do a certain application, it would be really nice if you measure the improvement. Like how well did it do better than before? What like to catch this insight that was missed by the previous data representation. You need to show two things. First, you are capturing or preserving more information, and you are making it easier for the LLM to deduce the relationship. And certainly you are not losing any other information, right? In an AI first world, owning data isn't enough. You must own the relationships that gives it life. And with this, we end today's workshop. I hope it didn't take too long for you. We still have a couple of minutes. We could take some questions and feel free. There's no bad questions.
Thank you
Sometimes
so
there
much,
is.
Dr. Ammar.
And
Um,
again, guys, feel free to connect with me on LinkedIn. That would be my absolute pleasure. If you have any questions and thoughts, I shared my LinkedIn again here in the chat.
Thank you so much, Dr. Ammar. If anyone has any questions, feel free to drop them in the chat box, and we also will be sharing the LinkedIn profile on the WhatsApp group as well.
So, don't you have any questions? So, like, it's like one of two options here. You either understood everything, or you have no idea what I'm talking about. And I hope it isn't the second one.
I believe the audience is amazed because it's a new topic and a new niche. They don't know much about it.
Okay, so could you please explain to me what's the difference between data visualization and this? Okay. Please, Sarah, could you send them the GitHub link again? They're asking for it. Okay, Hassan. So data visualization is about showing your data in this dimensionality. And that's totally fine. Nothing is wrong with that. Yet, our goal here is to change the data type. So we had a data of type audio. When you do data visualization, what would you visualize? Like how many audio files do I have in my data set? What's the length of the audio files? What's the sample rate? How many words per minute? Whatever, right? This is what you visualize. But when you do like graph modality representation, um, what happens here is that you the audio files are no longer used anymore. They are discarded, and you represent them with a graph data that basically is now, if you know a bit of deep learning, this is like feature engineering. So changing the modality. You had an image and you get the embedding of the image. You don't use the image anymore. The embedding now represents what was in the image. Makes sense, Hassan? Seems like we don't have, yeah, encoding, Ali. That's a way of encoding, but here, like the goal is different. We want to encode with more information and not less information, right? I hope you guys enjoyed this. It doesn't seem like you have any more questions. Feel free to reach out if you have any questions, thoughts, or idea you'd like to share. If you did a certain like demo, I would be happy to see it. And feel free.
Thank you so much, Dr. Ammar. And
This is my absolute pleasure.
interesting topic. I encourage everyone to dive into graphs specifically after today's session with Dr. Ammar.
Thank you so much.